3 years ago, I took keen interest in RC flying for the first time, and by that I mean YouTube videos. My favorite YouTube channel of them all is The Flight Test. Loved their videos and learned a lot from them. Another channel I love is the Rotor Riot. They specialize in race quads or drone racing with FPV. And man, FPV, first person view, one of the technologies I love the most. The fact that you can see live images from your aircraft on your FPV goggles and the feeling that you are yourself on the aircraft is literally an out of the body experience. Talking about FPV drone racing, Dubai held the first World Drone Peaks in March 2016 and it was owned by a then 15-year-old British teenager, Luke Bannister, beating about 150 other teams. Over the years, I learned about transmitters, receivers, brushless motors, ESCs, flight controllers, batteries, the list is endless. Then there is the company DJI. They make drones, camera equipments, stabilization systems for every needs. Back then they had Phantom 2s with bulky cameras or had to use other sports cameras with detachable gimbals. Then came the Phantom 3s, Inspire, etc. in 2015 with longer flight time and better cameras, even with 4K video recording capabilities. Then in 2016 they introduced the Phantom 4s and the Inspire 2 with features like obstacle avoidance. Now one of the major problems with these DJI drones were their size and the problems associated with transportation with them for normal people. Another great company popular with RC enthusiasts is GoPro. Their sports camera Hero lineup is the best for main video footage from the aircraft. And the small, light, waterproof, rugged Hero Session was the best the drone racing pilots could have asked for. Then in 2016, they along with their new Hero 5 and Hero 5 Session cameras, they released their own drone, GoPro Karma. And that, unlike the DJI drones, it was foldable, modular with their Hero 5 and could easily be carried in a backpack. But DJI was also not far behind, and only a few days later they released their new drone, the Mavic Pro, which was even smaller and more foldable than the GoPro Karma and could easily be carried in your pocket. Both of them had their pros and cons. And recently, DJI launched yet another drone, smaller than the Mavic Pro itself, geared more towards the general consumers for the Instagram savvy world, the new DJI Spark, with features like gesture control flight and shutter control. Well, enough of what's happening in the RC world. Let's come to the topic of this video. As you can already see by the title of this video, I bought my first radio control transmitter. According to me, the best place to buy RC equipments in India is rcbazaar.com. And no, this video is not sponsored by rcbazaar.com. Most of the equipments will cost you less than if you buy them from any other foreign website due to the delivery charge and import tax. But much of the time, many of the items will be out of stock and you will not be able to buy all the items you need for a standard RC project from there at once. You will have to look somewhere else. So from there I bought their own company Avionics RCB OS 10 channel telemetry FHSS radio transmitter, where RCB stands for RC Bazaar and OS might be for the fact that it is an open source system, and 10 as it has 10 channels, and FHSS stands for frequency hopping spectrum. For more about it, go to Wikipedia. Out of the box you will get the transmitter in bubble wrap, a receiver, a neck strap with RC Bazaar branding, a long red and black wire with connector to go with the receiver for battery voltage telemetry, and this 2-cell 8C 2200 mAh LiPo battery inside the battery compartment of the transmitter. You will also need a LiPo battery charger to charge the battery, and it does not come with the transmitter. On the side of the box you can see the main features, and it says that the transmitter is designed in India and France and manufactured in People's Republic of China. The most noticeable feature you will observe when you first see the transmitter is the antenna, and it is not folded sidewise as is the case with almost all the transmitters, but instead it is tucked inside it and can be pulled out and folded up while using the transmitter. It is a great feature to minimize unnecessary stress on the antenna during storage and transportation. Out of the box you will get the transmitter in mode 0, that is the y-axis of both the left and right sticks are spring-loaded. Generally transmitters come in either mode 1 or mode 2, mode 2 being the most popular, and if you want to change the mode you would have to open the transmitter up and remove the spring from one stick and replace it on the other. But in this transmitter you will not have to do any such modifications, as there is a slider behind the back of the transmitter to change the modes. When the slider is in the middle, the transmitter is in mode 0. You slide it to the right, the y-axis of the left stick gets unloaded off the spring and you get the mode 2. Same happens when you slide it towards the left and you get the mode 1. I haven't seen such a feature in RC transmitter from any other company. Another small feature, the handle behind the transmitter is also foldable and thus it is helpful during storage. The gimbals work fine and smooth and the sticks have adjustable height. There are 3 triple position switches and 1 2 position momentary switch. They are all snappy and works without any problem. And lastly, there are 2 potentiometers which feels okay with their plastic knobs. Also there are 4 dual position switches for digital trim, 4 buttons for the menu interface and a 3.5mm TS headphone jack or DSC port to be used for trainer or trainee connection and also for the simulation signal input for the simulators on PC. And inside the battery compartment there is a micro USB port to connect with the computer for firmware and file updates. Now let's take a look at the software or the firmware if you may call. Charge the battery, plug it inside and flip the power switch on. You are welcomed by a tone along with a vibration feedback and the branding of the avionic and name of the transmitter. Yes, the transmitter has vibration feedback feature. Then in the home screen you will see the 4 digital trim indicators for the 2 sticks, a logo of the representation of the model of the aircraft you are flying and its name. Then there are 3 timers. First one shows for how long the transmitter has been switched on. The second one shows the total time for which a battery is plugged into the transmitter. It resets when you recharge or replace the battery. And the third timer shows a custom countdown or count up to keep track of the time you have been flying. At the end of the time you get a beeping and vibration warning. At least you are supposed to get one. Then you can see the dual rates indicator. There can be 3 dual rates for the aileron, elevator, rudder and throttle. And lastly 2 battery voltage indicators, one of the transmitter battery and the other of the battery on the aircraft, and signal strength between the transmitter and receiver using the telemetry feature of the receiver. To get into the menu you have to press and hold down the enter button for about a second. There are 7 options under menu for different settings and monitoring, and the last one is about, showing the firmware version and few other information. First is the parameter settings. The options in this menu depend on the type of the aircraft set in the model settings. For example, if the aircraft is acro or glider, that is a fixed wing aircraft, then you get the options of mixer settings, where you can change and configure different types of mixings like the Delta 11, VTail, flap around, throttle mixing, aileron and rudder to elevator, and also aileron to rudder mixing. Then if the aircraft is set to heli, that is helicopter, then you get the options like gyro setting, pitch curve and swash. And lastly, if the aircraft is set to multi-rotor, then you will get the option of multi-mixer setting, where you can set the output of a channel based on the inputs of 2 switches. Other than these, you will always have the options of reversing and setting the endpoints of the 10 channels, sub-trim, stick and throttle curves, throttle hold value, setting up the virtual switches and auxiliary inputs, and setting servo delays for the 10 channels irrespective of the type of the aircraft. Then there is the model settings, where you can set and save the name, type, symbol for different models of the aircraft you have. You can store up to 25 models in the memory of the transmitter. There are also options to set the channel map and switch map. Channel map is simple. It is used to map the different functions like the throttle, elevator, rudder, gear, switch, etc. to the different channels of the transmitter. In the switch map, you can map the different switches and inputs to the different functions like the gear, flap, auxiliary 1 and 2 switches, and some advanced functions like throttle hold, idle and dual rate mode switches. There is a trainer menu to set a trainer for your transmitter using the PPM input of the DSC port using another transmitter as the trainer or master. You have the option of bind and RF, where you can set different parameters like the protocol, RF power, ID code, and the option to bind your transmitter with your receiver. There are 3 possible protocols, namely RCB6i for the 6 channel receiver, RCB-OS10 for the provided RZ10 receiver, and PPM to output PPM signal from the DSC port to be used during trainer or simulation on PC. And you can switch off all the signal outputs by setting it to off. And of course, the bind option doesn't work when the protocol is set to PPM or off, as there is no RF output in these protocols. You can also set the different levels of RF power with the maximum of 100 milliwatts. In ID code, you set a 6-digit ID to communicate between your transmitter and receiver in order to prevent channel overlapping with other nearby transmitters. You can also leave it in auto by setting all the digits to 0. After setting all the parameters, you get the option of Save RF Configuration. On pressing enter, the option changes to Bind, where you can bind with your receiver. We'll talk about the binding procedure a little later. You also have the option to copy one model to another model among the 25 models you can save in the transmitter. And lastly, you have the option to reset the model. These were all in the model settings. Then you have the transmitter settings shown as TX setting, where you can set things like trim step, which determines the change in output of signal per trim step change, stick mode, stick centering, which I do not have any idea about its function. You can set your vibration, sound, key volume, key tone, backlight brightness, contrast, backlight timeout, alarm volt to trigger an alarm when the battery level of the transmitter is below the set voltage. And lastly, you have stick calibration option. In the stick mode option, you will get options mode 2 and 4 if the left stick is not spring loaded, and if the right one is not spring loaded, then you get the options mode 1 and 3, and if both the sticks are spring loaded, that is in mode 0, then also you get the options mode 1 and 3, not mode 0. Stick calibration is fairly easy and simple. The range of value of the stick centering is from 0 to 50. I couldn't find any change in the signal outputs or different functions with the change of this parameter. So if you know, let me know in the comment section below. Then you get the timer settings. This is to set the third timer I showed you at the beginning. You can set the mode to count up or count down, or keep it off by setting it to INH or inhibited. You can set a switch to trigger the timer. It can be one of the 4 switches, though the dual position momentary switch is not really usable. And the throttle. If you use the throttle as the trigger for the timer, then you can set the position of the throttle above which the timer would be triggered using the throttle position option. You can of course set the alarm time and reset option to reset the timer, which doesn't seem to work ever. Then you have the receiver setting, where you can only set the warning alarm for the battery voltage level on the aircraft using the telemetry feature of the receiver. Then you have the monitor option to monitor the signal outputs of the transmitter of each channel. So this was mostly all of the transmitter and its firmware. Now let's take a look at the receiver. This is RZ10 10 channel long range receiver. There are 2 antennas and 3 rows of 10 pins for the 10 channels, and the 10th pin is marked S-bus for S-bus protocol communication with your flight controller board. There is no extra pin for binding, instead there is a dedicated button to bind with your transmitter. There is also the port for the battery voltage checker and a LED showing the status of the bind between the controller and the receiver. Now there is supposed to be a red LED here showing the status, as you can see here in the video by RC Bazaar, link in the I button. And that was even the case of mine when I first got it, but instead I have damaged it due to a wrong connection during powering up. Now there are 2 LEDs, red and blue, glowing together. The blue LED is not supposed to glow always. And then there is the bind button, which according to me shouldn't actually be called a bind button. You can bind with your transmitter without even clicking it. Instead it should be called a reset button. There are 3 states of the red LED. First, when it blinks rapidly because it is not bound to any transmitter and is continuously searching for bind request of any RCB OS10 transmitter. Then when it blinks slowly, denoting it is bound to a transmitter but not connected. It will be connected automatically when the transmitter is switched on. And lastly, when it glows solid, that means it is connected to the transmitter. In all these cases, consider there is no blue light. So now you can see the receiver is bound to the transmitter but not connected. If I switch on the transmitter, it gets connected automatically and the LED glows solid. Now you cannot disconnect them without switching off the transmitter. Now if the transmitter is switched off and you press hold the bind button, it will start to blink rapidly. That means it has been reset and not bound to any transmitter. And it will not connect when you turn on the transmitter. To connect again, you will have to go to the bind option and select it. It will bind and connect to your receiver automatically. No need to press the bind button. In fact, the bind signal stays for 10 seconds, but you won't even have to wait for that long also. Just select the bind option, the rapidly blinking red LED will start to blink slowly. You press the exit button and it will be bound and connected. When they show that the LED is blinking slowly and the transmitter is turned on, the receiver is actually bound to another transmitter and not connected to it. So when they select the bind option and press hold the button within the 10-second window, the receiver is bound, Actually, what is happening, the receiver is being reset, and as soon as it resets, it gets the bind signal from the transmitter and binds itself to it. So that's why I think the button on the receiver is actually a reset button, not a bind button. But there is another function of the bind button. Again, remember, the blue LED is not supposed to glow solid. It is because I most probably have damaged it. So when the receiver is bound and connected and the red LED glows solid, if you press and hold the bind button, you will get a blink of the blue LED. And then if you again press and hold the button, you will get 3 blinks of the blue LED. This happens alternatively. Most probably it is switching between the PWM mode and the S-Bus mode. To check it, we need a flight controller. I also bought an S32 flight controller from eBay for about 1000 rupees. I have provided the link in the description. I bought this to build a quad, though I am not sure when it will be possible. So I have connected the receiver with the flight controller using the PWM protocol. There are only 8 input pins in the flight controller, so you can't take the full advantage of the 10 channels in PWM mode. You can see all the channels are working properly. Now for the 10th channel marked as S-Bus, it also used to work properly at the beginning, but after the accidental wrong connection it has stopped working in the PWM mode. So if I connect the 8th pin of the Nest flight controller to the 10th channel, it does not work in the PWM mode. But if you connect the 4th pin in the flight controller to the S-Bus pin and configure the flight controller to work in S-Bus mode, it again works perfectly without changing any setting on the transmitter or the receiver. This time you can take advantage of all the 10 channels of the transmitter. So after all, the 10th pin of the receiver is not fully damaged. It is that I have permanently switched on the S-Bus mode on the 10th pin. Now let's talk about the open source aspect of the transmitter. Link to the software required to flash the firmware on the transmitter and the link to the latest firmware are below in the product description. Though the latest firmware is almost complete with all the major and necessary functions in place, it can look into some of the tiny bits to change in the graphics user interface, which I will talk about later. To update the firmware of your transmitter, load the latest .dfu firmware file from the repository onto the software. Then on the transmitter, while still being switched off, press hold the enter button and turn on the transmitter. It will switch on in the system update mode. Then connect your transmitter to your PC with an USB cable and select the proper device in the software and then flash the firmware. After it completes, turn off the transmitter. Then pressing hold the exit button, turn on the transmitter. Now it is in the flash storage mode and you will find the storage drive on your computer. Delete all the files in the memory and copy all the files from the folder udisk file in the downloaded firmware repository. These folders contains the files which you can easily change, like the icons and symbols according to your wish and liking. Like the logo you see when you turn on the transmitter is the file logo.bmp in the folder res or resources. I changed it and wrote my username in it and replaced the file in the memory. Now on turning on the transmitter you can see the modified logo. There is also the link to the GitHub repository for the source codes of the firmware, but it will lead you to a wrong empty repository. Just go back a level and select the other repository named Avionic RCB OS 10. Here are all the source code files. They are mostly .c files along with the header files and some others, but I have no idea how to compile or build the .dfu file from them. But one thing to notice, if you go into one of the .c file and look into the codes, you will find the comments are all written in the Chinese script, which shows the whole firmware was also written by Chinese programmers. So overall, this transmitter is manufactured and programmed in China. Now let's take a look at the negative aspects of this transmitter. There are only 10 inputs in the transmitter. For a 10 channel radio, it is really a low number. While using some features like the dual rates, trainer control and throttle hold, you can't use all the 10 channels. You will have to give up some of the channels. Instead, for about the same price range, in fact at a lower price, you can get the transmitter by Turnigy TGY i10, which is also a 10 channel radio but with far more inputs and greater community support. Then comes the software part, and most probably they can be fixed with its firmware upgrade, but the last firmware update was made on April 6, 2016. Minor details like whenever there is a change in icons or words, the whole screen is not refreshed, which results in parts of the previous graphics being left behind on the screen. For example, if you use the dual rates feature, there can be 3 rates and their symbols are like these respectively. But when you change them with a switch, they look like this. Then there is a problem with the custom timer in the count up mode. The alarm does not go off in the right time. And there is another glitch with the options view. Whenever there is a list of options, you get the double arrow symbol. And if you are at the end of the list, you should get this symbol because there is no other options below. Same when you are at the top of the list, you should see this, but instead it shows the opposite. Like here I am going down and at the end of the list you see this, and at the top of the list you see this. For different rates and mixes, it is necessary to have a switch assigned to each of the functions to turn them on or off, but it is not possible in this case because there are not enough switches to begin with. And most important of these is the hardware, and I am not sure about their quality or longevity. For example, after using this radio for about 6 months for studying the characteristics and features and using it on the PC for the simulators, while recording this particular video, the battery voltage reading started fluctuating, and as a result started to set off the warning alarm and subsequently switched off the transmitter. After some inspection, I found out that the power switch is the culprit. As I don't have that particular switch at my disposal at present, I instead connected two wires with the switch leads as a jumper and now turn on the transmitter from the battery compartment using the jumper. So should I recommend you to buy this transmitter, especially if you are buying your first transmitter? Well, it is up to you. If you think the 10 channels with foldable handle, interchangeable stick modes and retractable antenna is all you want, then go for it. And if you think you will need more switches and dials for your project, then look for something else. I bought this transmitter because I thought it was a really good product with outstanding features, and it is. There were online reviews, but you will not be able to understand its weaknesses until and unless you try it yourself. And it is also not that I know the transmitter completely. In fact, I am yet to apply anything with this transmitter. Hope this video was informative. This was my first review video and making this was not easy. If you liked it, smash the like button. If not, you are free to dislike. I will shortly be coming up with my first airplane build and flying video. So for that, subscribe to my channel and you can follow me on Instagram at @Rajduino. Thank you.